Good morning, students. Today we will study about probability. In probability, there are certain objectives which we have to consider. First, we will learn about the experiments, then the sample space, event, types of events, probability of an event, and we'll have some exercise. So we start with the sample space. The sample space of a random experiment is the set of all the possible elementary outcomes, and it is denoted by capital S. Then we have an example for that. If we toss a coin, the sample space S will become H, T. There will be two possibilities, head and tail. So it is a random experiment because when we toss a coin, this time we do not know whether we shall get head or a tail. The next example is when we throw a die, the sample space will become 1, 2, 3, 4, 5 and 6. Any of the number can be obtained when you throw a die. Now come about the event. What is the event? An event is a subset. E of a sample space is called an event. An event is a combination of one or more of the possible outcomes of an experiment. For example, in a single throw of a die, the event of getting prime number is given by E is equals to 2, 3, 5. And the sample space will be right from 1 to 6. All the elements will come. So easily we can say that E is a subset of S. That is, event is the subset of sample space. Now we come to the algebra of events. For any three events A, B and C with sample space S, the first one is A union B. That is, either A or B or both can happen. The next is A intersection B, when both A and B are possible. The third algebra is when the event is not happening, not A, that is represented by A complement. And A minus B can be represented as A but not B. Similarly, if we have A union B whole complement, by using the De Morgan's law, we can say that it is A complement intersection B complement. Now we have certain types of events which are possible. The first event is, that is sure event, when the chances of happening any event is 100%. For example, in a throw of a die, sample space will become 1, 2, 3, 4, 5 and 6. S is the subset of S because we know that every set is a subset of itself. It represents an event. Each outcome of an experiment is a member of S. Therefore, S is called a sure event or a certain event. Next possibility is impossible events, when we throw an event and nothing happens. For example, in a throw of a die, sample space is as such 1, 2, 3, 4, 5 and 6. Let E be the event of getting an 8 on the die. Clearly, no outcome can be a number 8 because we know that the faces are 1 to 6 only. So E is equals to 5, which is an impossible event. Complement of an event E can be represented as not E or S minus E. From the whole sample space, if we subtract the events E, then we get the complement of an event. The next event is simple event and compound event. So first we talk about the simple event. An event that contains only one element of the sample space is called a simple or an elementary event. Next, the compound event, a subset of a sample space which contains more than one element is called a compound event, or mixed event or a composite event. For example, in a simultaneous toss of two coins, the sample space is HT, TH, HH and TT. Even if we consider of getting both tails is an elementary event because it contains only one sample point. Event E2 we consider getting at least one tail is a compound event because it contains more than one sample point. Now we come for the next step, that is equally and likely outcomes. The outcomes are said to be equally likely if none of them is expected to occur in preference to the other, or the chances of occurrence of all of them are same. For example, in throwing of single die, each outcome is equally likely to happen. Now we come for the next, that is mutually exclusive events. Mutually exclusive events are those events when two or more events are said to be mutually exclusive if no two or more of them can occur simultaneously in the same trial. So two events E1 and E2 are mutually exclusive if E1 intersection E2 is a null set, that is, they are the disjoint sets. There are certain facts about this. The elementary events related to an experiment are always mutually exclusive events. Second, compound events may or may not be mutually exclusive because there may be some sample points which can be common to both of them. For example, in a throw of a die, the sample space is 1, 2, 3, 4, 5 and 6. If we consider event E1 of getting a number less than 3, E2 with the event getting a number more than 4, then E1 is equals to 1, 2 and E2 is equals to 5, 6, which imply E1 intersection E2 is a null set. So they are known as mutually exclusive events. Now we have another type, that is exhaustive events. In a random experiment, two or more events are exhaustive if their union is the sample space. That is, in a random experiment, E1, E2, E3 till AN with sample space S are exhaustive if E1 union E2 union E3 and so on till union En is equals to the complete sample space. We take an example for this. In a throw of a die, the sample space S is equals to 1, 2, 3, 4, 5 and 6. Even if we consider an event 1, 2, that is the event of occurrence of 1 or 2. We take another event E2, that is the event of occurrence of 2 or 3 or 4. Another event E3 we consider the event of the occurrence of a number greater than or equals to 3. We observe it here, E1 union E3 completes the sample space, E1 union E2 union E3, it also completes the sample space. So all these two events are the exhaustive events. But we will find it here, E1 union E2 is not equals to the sample space. So combining E1 and E2 will not be an exhaustive events. Another example we consider, three coins are tossed. Now we have to describe first two mutually exclusive events A and B, another three mutually exclusive and exhaustive events A, B and C, third two events E and F which are not mutually exclusive. So we take this solution. The sample space for the toss of the three coins, there will be 8 elements, triple H, HHT, HTH, THH, HTT, THT, TTH and all the three tails. Event A, that is event of getting 3 adds, it will be H, H and H. Event B we consider of getting 3 tails, T, T, T. We find nothing is common between them, so they are known as mutually exclusive events. Another, let's see with the event getting 1 or more 2 heads. A, B and C are mutually exclusive as well as exhaustive events. Another example if we take, let E, event of getting 2 heads, that is HHT, HTH and THH. Event F of getting at least 1 tail, that is HHT, HTH, THH, HTT, THT, TTH and all the 3 tails. E and F are not mutually exclusive events because certain elements which are common to both the events. Now we come for the next part, that is probability of an event. In a random experiment, the probability of happening of the event A with sample space S is defined as PA, that is the number of outcomes favorable to A upon the total number of possible outcomes, which can be represented as NA upon NS. If M is the number of outcomes favorable to an event and N is the total number of possible outcomes, then it can be represented as probability of A is equals to M upon N, that is the favorable outcomes upon total outcomes. Clearly, M lies between 0 and N, and if we divide by N, we get M upon N, that is the probability of A lies between 0 to 1. So the probability of any event always lies between 0 and 1. Now, if we take an example of a sure event. Any event A is said to be a sure event or certain event if its probability is 1. Similarly, impossible event, an event A is said to be impossible if its probability is 0. Now there are certain other definitions, that is odds in favor of occurrence of an event A are defined as n ratio n minus m. That is ratio of the favorable outcomes to the unfavorable ones. And the odds against occurrence of an event A are defined as n minus m, ratio m. That is the ratio of unfavorable outcomes to the favorable ones. We take an example for that. What is the probability of getting at least 2 heads in a simultaneous throw of 3 coins? The solution is, if 3 coins are tossed together, possible outcomes are HHH, HHT, HTH, THH, TTH, THT, HTT and TTT. Number of these exhaustive outcomes NS is equals to 8. Now at least 2 heads can be obtained in the following ways. If we consider event E, HHH, HHT, HTH and THH. Number of favorable outcomes to this is 4. As we know, the total outcomes are 8, therefore the required probability will become 4 upon 8, that is 1 upon 2. We consider another example. The letters of the word society are placed at random in a row. What is the probability that 3 vowels came together? Solution for this solution will be, there are 7 letters in the word society. These 7 letters can be arranged in a row in factorial 7 ways. O, I and E are the 3 vowels in the word society. Assuming these 3 vowels as 1 letter, we get 5 letters which can be arranged in a row in factorial 5 ways. But 3 vowels O, I and E can be arranged itself by factorial 3 ways. Therefore, the total number of arrangements in which 3 vowels come together is factorial 5 into factorial 3. So the required probability will become factorial 5 into factorial 3, which is the favorable outcome, upon total favorable outcome, that is factorial 7. So the answer will become 1 upon 7. We consider another example for the probability. If we consider a 5-digit number which is formed by using the digits 1, 2, 3, 4 and 5 without repetition, then we have to find out that the number is divisible by 4. Here we find that the total number of ways in which a 5-digit number can be formed by the digits 1, 2, 3, 4 and 5 is factorial 5, that is 120. A number is divisible by 4 if the numbers formed by last 2 digits are divisible by 4. Thus, for an outcome to be a favorable, the last 2 digits can be 1, 2, 2, 4, 3, 2 and 5, 2. The last 2 digits can have only these 4 arrangements, but the rest of the 3 digits can be arranged in factorial 3 ways. Thus, for an outcome to be favorable, the last 2 digits can be this. Therefore, we say that the number of favorable outcomes is equals to factorial 3 into 4. The required probability is 1 upon 5. Thank you, students.